We have a molecule here with 4 carbons, and there's 2 chlorines on it. So this is reminiscent of the molecule on 154 in your book, 4-carbon molecule that has OHs at each position. Question is, this molecule with 2 chiral centers can exist in possible 2 to the second or 4 possible stereoisomers. Let's look at those and see if actually all those exist. Let's look at the enantiomers, diastereomers, and see if there's any meso compounds. So first of all, we have the RR form. We know we can immediately make another one of the isomers by just changing the R designations to S. And in doing so, we're just interchanging 2 groups on each carbon, the Cl and the H. So now the Cl is pointed to the back, the H would be pointed to the front. We leave that out because it just clutters up the diagram. So likewise, this chlorine is coming out here. Now the question is this molecule superimposable on this? And I think you would agree that if I were to lift this up and put it on here, the answer would be no. So it appears like they're mirror image, non-superimposable isomers or enantiomers. But let's do some rotations around this molecule just to verify that. And as we do so, let's rotate it around the vertical axis. And if we do so, 180 degrees, now this bond would be pointing in this direction. Of course, if we flip the molecule 180 around this axis, the Cl is coming out. This Cl would be coming out as well. Now let's take this molecule. We want to see if it superimposes on this. Well, then this carbon coming is pointed down here. It's pointed up here. Let's flip it on this axis. And in doing so, we produce this molecule, which, you know, this is very same as this molecule. So all of these are the same. We haven't done anything but rotate them. And we're back to the conclusion that no matter how I flip and turn this molecule, it's not superimposable in its mirror image. So they are non-superimposable enantiomers. Now to make another one of the possible stereoisomers, let's just change one of these R designations. We'll go to the RS. And again, the chlorine was pointing out, now it's pointing in. So now let's take this molecule and switch both designations, and we see now we have the SR form. And again, the chlorine was pointing back on this carbon when it was pointing out in the beginning. So the question is, are these superimposable on each other? Well, in this case, it sort of doesn't look like it, but maybe we do some clever rotations, we can show that it does. So let's rotate this molecule around this vertical axis. And in doing so, this Cl now would be pointed up like this. I mean, this carbon would be pointing up. This Cl, which was pointing out, now must be going down. Likewise, this Cl that was pointing out must be coming up. We haven't pointing outward. We haven't changed in the RS designation. Now, question is, can this molecule superimpose on this? And again, it's a little hard to say because, you know, this carbon here is pointing up where the second carbon here is pointing down. So let's flip it one more time, and in doing so, we get this molecule. Now, let's say, can this molecule superimpose on this? And lo and behold, it can, which is pretty amazing because we thought that we made 2 different stereoisomers of them, but it turns out there's symmetry in this molecule, as we'll see on the next slide. And that by simple rotations, remember all these 3 molecules right here are all the same because all I've done is rotate around axes. I haven't inverted any stereochemistry. So the fact that I can superimpose this molecule on this suggests that they're identical, that we don't have 4 possible. All possible stereoisomers, only 3. 2 of these are identical. These are example of meso compounds. In the previous class, we said that really you can tell right away if a molecule maybe can exist as an enantiomer. If there's a plane of symmetry in it, then it cannot exist as an unsuperimposable mirror image isomer. So let's take a look at our example here. Remember we had in our first example, we had RR, the chlorides, the chloride are coming out. So we have a chloro and a chloro coming out. Now let's look down this bond. It's really hard to see a plane of symmetry here. But let's do a little rotation. Let's rotate around this bond right here. And you see this Cl is coming out with respect to the H. Let's rotate around here. And here we have another version. The Cl is still coming out with respect to the H, but we're going to make this H now sort of in the plane of this. And this green methyl group goes to the back. So if we do so, we just rotate a little bit around that axis. You can see, let's try to put a mirror plane here. And across this mirror plane, the Cl's are coming out. That's cool, but the H over here on this carbon is not matched by an H over here going back. It's a CH3. So hence there's no mirror plane here. That means this molecule can actually exist as a mirror image isomer itself. And of course I could just go from this particular version to this version here, in which I went from the RR to the SS. Again, there's no plane of symmetry, so these exist as enantiomers. Now let's look at the other example in which we had the RS version. Again, one, the Cl was coming out, the other, the Cl was going down in the carbon, the RS, going back into the plane. So let's, again, sight down here and do a simple rotation. And in doing so, we can produce this molecule right here. And I think you can see the Cl is coming out, the H is going back. That would happen if we rotate that enough around here. And the idea is we wanted to align these two Cl's that are adjacent to each other and see, well, let's look at the other atoms attached to these two carbons. And now you can see we have a plane of symmetry here. I have the H pointed back and the H pointed back, and I have two methyl groups pointed here in the plane. So there's definitely a plane of symmetry here. That means this molecule cannot exist as a mirror image isomer that's non-superimposable on itself. So in other words, these are identical molecules. So I mean, if I tried to make this this is the RS, if I was simply to try to change the designation to SR, in fact, what we can show with this simple sort of rotational comparison is that these two are superimposable on each other, so they're not enantiomers because they're superimposable, even though they appear to be mirror images of each other. So this is an example of meso compound. Now,